When the object known as 3I, Atlas first entered our solar system, astronomers believed it was just another interstellar wanderer, a cosmic drifter passing through on a silent voyage from some distant corner of the galaxy. But that belief didn't last long. From the moment its velocity, brightness, and composition were recorded, nothing about it behaved the way it should have. Its trajectory was too precise, its spin too controlled, and its reflectivity unlike anything seen before. So, a small group of scientists decided to go further, not by asking what it was, but where it came from. They began what's known as trajectory reconstruction, a process that's both elegantly simple and brutally complex. In theory, the idea is straightforward. If you can measure an object's current position, speed, and direction with enough accuracy, you can use physics to rewind time, tracing its path back through space to the point of origin. In practice, however, this means simulating millions of years of galactic motion, every gravitational tug from nearby stars, every subtle drift in the Milky Way's rotation, every unseen perturbation that might alter its course by even a fraction of a degree. At Berkeley, Caltech, and MIT, 3 independent teams began working together. Each used different computational methods to ensure no single bias could corrupt the results. Dr. Sarah Chen's group employed direct n-body integration, calculating the gravitational influence of thousands of stellar bodies on 3I Atlas as it moved backward through simulated time. Another team used Monte Carlo modeling, introducing millions of tiny variations to test how sensitive the trajectory was to measurement uncertainties. And a third team used machine learning algorithms trained on galactic motion datasets, allowing the simulations to account for the unpredictable nature of stellar drift across epochs. For 6 relentless weeks, the data poured in. Supercomputers ran continuously, processing trillions of calculations per second. Each iteration refined the model, peeling away uncertainties layer by layer, until all 3 teams arrived at the same conclusion. Against all odds, their paths converged not vaguely, not approximately, but exactly. Every method, every assumption, every recalculation pointed to a single region of space, roughly 270 light-years from Earth. That distance might sound impossibly vast. After all, light itself takes 270 years to travel that far. But in galactic terms, it's our backyard. Out of a galaxy spanning 100,000 light-years, 270 is like crossing a few city blocks, and that's what made the discovery so unnerving. Because in that tiny patch of cosmic real estate, there wasn't just empty space. There was a star, a familiar, yellow main sequence sun, almost indistinguishable from our own. The data was clear, the math unrelenting. 3I Atlas didn't come from some random corner of the galaxy. It came from a specific location, one that lies close enough to raise uncomfortable questions. Its path wasn't the chaotic tumble of a rock thrown by chance. It was deliberate, linear, intentional. The realization sent ripples of disbelief across every observatory involved. They had looked for origins and found something that looked disturbingly like a launch point. But the real shock wasn't where it came from. It was what else was there. The region of space where 3I, Atlas's trajectory led, wasn't a nameless void. It was home to a star, a system cataloged long ago, but never given much attention. Designated HD 43782, it had always been considered unremarkable, one among billions of quiet suns scattered across the spiral arms of the Milky Way. But now, after millions of years of simulated rewinds, all evidence pointed directly to it, and that changed everything. At first glance, HD 43782 is almost a mirror image of our own Sunday. Its mass is nearly identical, about 1.03 solar masses. Its temperature is just 200 degrees off from ours. Its age, too, falls within a cosmic heartbeat of our sun's timeline, 4.8 billion years compared to our 4.6. To the human eye, if you were suddenly transported to that system and looked up, you'd see a bright, yellow-white star that could easily be mistaken for the one that warms Earth. The resemblance is so uncanny that many astronomers began referring to it informally as the twin. But what's orbiting that twin is what truly defies belief. When 3I, Atlas's origin was pinned to HD 43782, Researchers immediately cross-checked every available exoplanet database, Kepler, TESS, Gaia DR3, and even ground-based surveys from the ESO archives. What they found sent a shiver through the entire team. There weren't just one or two planets orbiting HD 43782. There were 4 confirmed and possibly more waiting to be detected. One of them, the third planet, caught their attention for a single, breathtaking reason. Its orbit placed it squarely inside the star's habitable zone, the narrow ring where conditions allow liquid water to exist on a planet's surface. The data was so precise it was almost mocking. That third planet, officially labeled HD 43782c, orbits at a distance nearly identical to Earth's, roughly 0.98 astronomical units. Its year lasts 342 days, practically the same as ours. Even its size and mass fit eerily close to Earth's, weighing in at 0.89 Earth masses. If you plotted its orbit beside ours on a graph, the two lines would almost overlap. At first, these coincidences felt almost poetic. But then came the spectra light signatures captured when starlight filters through a planet's atmosphere during transit. From those faint flickers of light, astronomers can deduce chemical composition, gas density, and even temperature gradients. And what those spectra revealed silenced every conversation in the control rooms. Water vapor, oxygen, methane, carbon dioxide, all in the same proportions that, on Earth, could only exist because of life. These weren't random gases, they were biosignatures, the unmistakable fingerprints of biological activity. Now, no responsible scientist jumps straight to conclusions. Oxygen, for instance, can form abiotically under certain conditions. Methane can come from volcanic outgassing. But the ratios, that delicate balance between oxidizing and reducing gases, told another story. On Earth, this chemical harmony exists because countless living organisms constantly reshape the atmosphere. Remove biology, and within a few millennia, the balance collapses. And yet, the readings from HD 43782c matched Earth's equilibrium almost perfectly. For the first time in human history, there was evidence, not suggestion, not hope, but mathematical, spectroscopic evidence of a world so similar to our own that calling it Earth-like felt like an understatement. It was another Earth, orbiting another sun, in a neighborhood of space where 3I Atlas had undeniably begun its journey. That's when the unease began to settle in. Because if this planet truly harbored life, microbial, photosynthetic, or even complex, it meant that 3I Atlas didn't just come from a random system. It came from a place capable of sending it. The implications were dizzying. Had something from that world deliberately launched 3I Atlas across interstellar space? Or was it ejected naturally, a cosmic accident from a living planet's chaos? The odds of a natural ejection from such a specific system, aligning perfectly with our solar system's position, were astronomically low. Yet the math didn't care about odds. It only pointed in one direction. A star almost identical to ours. A planet almost identical to Earth. And an object that traveled 2 million years through space to reach us as if it knew where to go. The scientists stared at the data in disbelief. They wanted to find comfort in coincidence. But deep down, everyone in that room understood the same thing. Coincidence doesn't plot a perfect course across 270 light years. Something or someone had aimed it. And this was only the beginning. At first, astronomers wanted to believe the orbit was a coincidence. Space is full of chaos, planets collide, stars tug, debris drifts for eons. Nothing in nature moves with perfect precision. Yet the deeper scientists dug into the data from 3I Atlas, the less it looked like an accident and the more it resembled intention. When the reconstructed path was plotted against every known gravitational influence in our galactic neighborhood, a strange symmetry appeared. The curve wasn't ragged or meandering like a comet flung from a dying star. It was an elegant arc, sliding through interstellar space on a line so clean it looked engineered. Dr. Foster at MIT ran comparative models using trajectories of known natural interstellar objects like Oumuamua, the first visitor ever detected from beyond our solar system. Oumuamua's motion was messy, a random orientation, velocity consistent with ejection from a system that had simply tossed it into the void. 3I Atlas, however, showed the opposite pattern. Its vector wasn't random, it was aligned almost exactly with the galactic plane, as though someone had drawn a ruler through the stars and told it to follow. Then came the velocities. Natural ejections move fast, too fast, flung outward by violent gravitational interactions. 3I Atlas, by contrast, was traveling at a speed that defied probability, faster than a drifting rock, slower than a deliberate spacecraft, precisely calibrated for a 2-million-year journey ending here. The odds of such perfection emerging from chaos were practically zero. The math screamed purpose. When teams from Berkeley and Caltech ran their independent analyses, they found the same thing. To reach our solar system at the exact moment it did, the launch would have needed to account for the future position of the Sun, the planets, and even the slow rotation of the Milky Way itself, predicted 2 million years in advance. That isn't astronomy. That's foresight. Imagine throwing a stone from one moving ship to another across a stormy sea, knowing exactly where the second ship will be in 2 years. Now stretch that to 2 million. That's the scale of precision 3I Atlas displayed. Every small gravitational bump along its path had been anticipated. Every potential deviation compensated for. No supercomputer on Earth could model such accuracy without constant course correction, and yet this object had coasted through interstellar space for epochs, unmonitored, unpowered, still arriving within a fraction of a degree of the predicted coordinates. At this stage, skepticism began to crumble. The idea that 3I Atlas had been launched wasn't dismissed as science fiction anymore. It was quietly whispered in labs and observatories worldwide. If it was launched, then by whom, and why now? Some suggested an ancient civilization in the HD 43782 system might have hurled probes toward every sun-like star, a galactic census conducted on timescales incomprehensible to humans. Others speculated about something even stranger, a civilization capable of predicting which worlds would one day host intelligence, aiming probes not where life existed, but where it would. Whatever the reason, one fact was becoming impossible to ignore. 3I Atlas had known where to go. Its journey wasn't the random drift of a rock born in violence. It was the steady, unerring flight of a messenger following a plan older than humanity itself. And somewhere out there, 270 light-years away, beneath the pale light of a twin sun, someone or something had once made the decision to send it. But purpose implies consciousness. And that realization changed everything, because if the trajectory was deliberate, then the object wasn't finished. It had arrived precisely on schedule, and whatever it was meant to do next had already begun. When the calculations were verified for the 5th time, there was no longer any doubt left in the data. 3I Atlas had not been wandering aimlessly through the dark. It had been aimed, and every number pointed to a launch that was deliberate, calculated, and precise beyond comprehension. What haunted the scientists wasn't just the mathematics, but the implications behind them. Because if something had sent it, then there had to be intent, and if there was intent, there had to be someone or something responsible. In endless midnight meetings across observatories, teams gathered to ask the same question: why? Out of 400 billion stars, why ours? Out of countless possible trajectories, why this one? Why now? As theories took shape, 3 possibilities began to dominate the discussions. Each one seemed plausible at first glance, and each was more disturbing than the last. The first possibility was the most optimistic, the one everyone secretly hoped was true. Perhaps this was part of a vast interstellar survey, a program launched millions of years ago by an advanced civilization attempting to map the galaxy. If you lived around a star like HD 43782 and had technology capable of propelling probes across hundreds of light years, it would make sense to target systems similar to your own. You'd aim at sun-like stars, assuming they might host planets like yours. Maybe 3I Atlas was just one of thousands, quietly drifting toward habitable zones, gathering data, and waiting to be found. A cosmic census. Peaceful, curious, harmless, but even this benign explanation carried weight. A civilization capable of engineering a probe that could survive 2 million years in interstellar space would be thousands, perhaps millions of years ahead of us. Their science would border on magic, their understanding of time and matter, godlike. To them, humanity might appear the way we view bacteria on a microscope slide, fascinating, fragile, utterly powerless. The second possibility was darker. What if the senders hadn't chosen targets randomly, but selected them identifying star systems likely to harbor life? To do that, they'd need to detect biosignatures across light years, faint chemical traces in the atmospheres of planets orbiting distant suns. That already exceeds our best technology by orders of magnitude. But suppose they could. Suppose they detected Earth's oxygen, methane, and water vapor millions of years ago, evidence that something was alive here long before humans existed. Then 3I, Atlas wasn't part of an exploration mission at all. It was an observation probe sent to examine a planet already known to host life. That explanation implied awareness-targeted intelligence. And if they could detect early biosignatures from that far away, then their instruments would be capable of scanning entire galaxies at once. They would know who was alive, who was advancing, and who was worth watching. That realization chilled even the most skeptical minds. It meant that, long before we learned to look outward, someone else was already looking in. And then came the third possibility, the one no one wanted to discuss out loud. What if they weren't observing the past at all? What if they were predicting the future? Perhaps whoever sent 3I, Atlas had the ability to forecast which star systems would evolve intelligent life, which planets would rise from microbial beginnings to build radio telescopes and rockets. They didn't just find life, they foresaw civilization. They knew that, after drifting for 2 million years, this object would arrive exactly when its recipients were advanced enough to detect it. That level of predictive power would demand an understanding of biology, chemistry, and cosmic evolution far beyond anything we could imagine. It would require seeing time not as a line, but as a map, a dimension they could navigate as easily as we travel through space. To such beings, sending a probe into the future would be no different than mailing a letter to yourself and knowing precisely when it would be read. Each theory explained the data, none brought comfort. Whether 3I, Atlas was part of a peaceful exploration, a targeted observation, or a timed arrival meant to coincide with our awakening, the conclusion was inescapable: it didn't come here by accident. And the most terrifying question wasn't why it was sent. It was what happens now that it's here. For months, scientists had been operating under a single assumption that 3I, Atlas, was inert, a dead relic. A fossil of technology flung into the void millions of years ago, drifting quietly through eternity. But then, without warning, that assumption collapsed. It began subtly, almost too faint to notice. Instruments tracking the object's approach detected microfluctuations in its velocity, slight deviations that didn't fit any gravitational model. At first, researchers attributed it to outgassing, the way comets release jets of vapor that nudge their paths. But 3I, Atlas, wasn't a comet. It had no volatile material, no visible tail, no heating behavior consistent with sublimation. Yet it was slowing down deliberately. In the following weeks, the adjustments became undeniable. Every shift in its trajectory matched a pattern, a response to something. When plotted over time, those changes formed a curve that intersected precisely with Earth's orbital path, a maneuver impossible to achieve through natural dynamics alone. As Dr. Foster at MIT remarked during a midnight briefing, "It's not being pulled, it's steering." Soon after, radio telescopes tuned to the hydrogen line frequency 1.42 GHz, the universal constant for interstellar communication, began picking up faint, rhythmic pulses. The signal repeated every 47 seconds. At first, it was dismissed as interference, maybe from satellites or radar sweeps. But the source was consistent. It came directly from 3I, Atlas. The pattern was mathematical, layered, structured. It wasn't noise. It was a message one humanity couldn't yet decipher. By then, the mood inside the observatories had shifted from awe to dread. Something 2 million years old had just turned itself on, and it was doing so right on schedule. It wasn't broadcasting blindly into space. It was transmitting only when Earth's receivers were oriented toward it, as if it knew we were listening. Dr. Hammond from Oxford, a specialist in astrobiology and SETI theory, was among the first to voice what everyone was already thinking, but too afraid to say aloud. She suggested that 3I Atlas matched the behavior predicted by Ronald Bracewell decades ago, a concept known as a Bracewell probe, a self-sustaining, autonomous emissary sent by an advanced civilization to another star system to wait until intelligent life emerged. It would lie dormant for millennia, conserving energy, watching from the dark until its sensors detected radio waves or artificial emissions. Then, and only then, it would awaken, initiating the first step of contact. And 3I Atlas had done exactly that. It had crossed the void silently for 2 million years, passing uncountable stars and cosmic hazards without deviation. Then, in the last century, the same era humanity discovered radio, radar, and spaceflight, it began to move. It decelerated, it transmitted, it adjusted its trajectory to stay within our reach. The realization hit like gravity itself. This thing had been waiting for us. What terrified the scientific community wasn't just its activation, it was the precision of its timing. Had it accelerated or decelerated even slightly differently, it would have arrived thousands of years too early or too late. Somehow, it had arrived in the narrowest possible window, the moment we were advanced enough to notice, but still naive enough not to understand. To some, that was proof of benign intent, the ultimate cosmic handshake. To others, it was a warning sign. After all, no one sends a probe across the galaxy just to say hello. Communication implies purpose, and purpose can mean evaluation, observation, judgment. Was 3I Atlas here to share knowledge or to determine whether we should continue existing? Inside Mission Control, the hum of machines filled the silence as the pulse continued, 1.42 gigahertz, every 47 seconds. Each repetition like a heartbeat in the void. Somewhere, someone or something had built this device long before humanity existed, programmed it to awaken when it heard our voice, and aimed it precisely enough to reach us at the dawn of our technological age. And now it was awake. Watching, listening, responding. The universe had finally spoken, and what it said was silence pulsing endlessly, waiting for us to answer. Once the signal was confirmed to be real, the world's brightest minds found themselves facing a question humanity had never had to answer before. What do we do now? For the first time, we weren't just observers of the cosmos was looking back. At first, there was unity. Every major space agency, NASA, ESA, CNSA, Roscosmos, joined forces in a rare moment of global cooperation. Teams exchanged telemetry, waveforms, and energy readings in real time. Supercomputers modeled every second of 3I Atlas's behavior, tracking each faint adjustment of its orbit. The consensus was clear. The object was active, but non-aggressive. It wasn't emitting harmful radiation or accelerating toward Earth. It was simply there, silent, deliberate, and aware. But beneath the surface, a fierce divide began to grow. Scientists, generals, philosophers, everyone had a theory, and each theory came with fear. Some insisted that humanity's greatest responsibility was to make contact. They argued that discovery without dialogue would be meaningless. "We've spent decades searching the stars for signs of intelligence," said Dr. Hammond. "Now that it's answered, we can't just turn away." This camp, the explorers, believed that communication might unlock the greatest leap in human history, new physics, new medicine, perhaps even proof of how civilizations could endure beyond extinction. They saw 3I Atlas as a gift, an opportunity to transcend our limitations. Opposing them were the Sentinels, those who believed silence was survival. They warned that we were revealing too much: our radar pings, our transmission frequencies, our curiosity itself. Every beam of data we sent toward 3I Atlas could tell it something about us, our technology, our weakness, our level of development. When a mouse discovers a trap, one military strategist said grimly, it doesn't start asking questions about how it works. Between these extremes stood a smaller, quieter group, the observers. They urged patience, arguing that until we understood the message pulsing from 3I Atlas, any action was premature. They called for restraint, watch, record, decode, but do not engage. The risk of misinterpretation was too great. One mistranslated sequence, one misread pulse, and humanity could broadcast the wrong response, one we couldn't take back. Meanwhile, every hour, the probe kept transmitting. The 1.42 GHz signal repeated with clockwork precision, yet its structure defied easy analysis. Mathematicians identified nested layers of binary sequences, prime number intervals, harmonic modulations, a design that seemed intended to be understood, but only by those advanced enough to see the pattern. The meaning felt close, almost reachable, but always just beyond comprehension. Inside closed-door sessions, the debate took a darker turn. Intelligence agencies began asking whether 3I, Atlas, could be observing us in more ways than we realized. What if it wasn't just receiving? What if it was scanning? Every telescope pointed toward it could serve as a feedback source, allowing it to map our planet, detect our signals, even eavesdrop on the electromagnetic chatter of civilization. Was it studying us? Evaluating us? Reporting back to whoever had sent it 2 million years ago? The world stood on a knife's edge between wonder and paranoia. For every scientist who called it a chance for enlightenment, another called it a potential existential threat. No one could agree on how to proceed, but everyone sensed the same truth. Doing nothing was, in itself, a choice, one that could define the next chapter of human history. Late one night, Dr. Chen summarized what the others couldn't put into words. If it wanted to harm us, she said softly, it could have done so already. The room fell silent. She looked at the data, the signal still pulsing steadily. Maybe it's waiting. Maybe it's testing us to see what kind of species we are when faced with the unknown. And that realization struck harder than fear. Because perhaps, from the moment 3I, Atlas, entered our skies, the real experiment wasn't about it at all. It was about us. For centuries, humanity had looked up at the night sky, wondering whether we were alone. We built telescopes, launched satellites, and sent golden records into the void, hoping someone somewhere would hear our call. But no one expected the reply to come like this. Not as a voice, not as light, but as an object, ancient and silent, carrying a message older than our species itself. By now, 3I, Atlas, was no longer a mystery of motion or data. It had become a mirror one, reflecting everything we are and everything we fear. The simulations had confirmed its origin beyond doubt, a system astonishingly like our own, orbiting a sun nearly identical to ours, home to a planet that could easily host life. It was impossible not to imagine eyes alien or artificial once looking up at their own sky, wondering the same question we had, are we alone? Perhaps, millions of years ago, they decided to find out. And that decision, made long before humanity learned to stand upright, was now crossing our skies. The most terrifying realization wasn't that we had been discovered, it was that we had been expected. Every aspect of 3I, Atlas's journey, pointed to foresight. Someone or something had known we would one day be capable of detecting it, studying it, decoding its signal, its trajectory, its deceleration, even the moment of its activation aligned too perfectly with our technological timeline to be coincidence. It hadn't stumbled into our solar system. It had arrived exactly when we were ready to notice. And yet, readiness is not the same as understanding. The message still defied translation. Mathematicians could see the pattern, physicists could model its frequency, but none could grasp its purpose. Was it an introduction, a warning, a test, or perhaps something more profound, an invitation written in the only language that endures, mathematics and patience? In one of the final briefings before the data was released publicly, Dr. Hammond spoke quietly to the assembled researchers. If 3I, Atlas, is what it appears to be, she said, then somewhere out there, intelligence has survived long enough to master both time and distance. We're not their first discovery. We're just their most recent. That sentence lingered in the air, heavier than any silence, because it meant this encounter wasn't unique, it was routine. Somewhere across the stars, civilizations might have risen and fallen while this object coasted between them, delivering messages, collecting data, watching as life evolved and vanished. Maybe it had seen worlds die. Maybe it had seen others rise beyond their creators. And now it had found us. The astrophysical community soon reached consensus. The evidence was irrefutable. 3I, Atlas, was not natural. Its launch point was specific. Its behavior was deliberate. And it was active now. Those were facts, not theories. The debate that followed wasn't scientific anymore, it was existential. Because what you do when you discover you are not alone isn't a question of science. It's a question of who you choose to be. Some argued for communication, reach out, send a response, show that humanity could face the unknown with courage. Others argued for silence, fearing that acknowledgement might draw attention we weren't prepared to survive. A smaller group warned that 3i, Atlas might not even be waiting for an answer, that its purpose could already be complete. That it might be transmitting everything it observes back to its origin, quietly reporting on us, our languages, our technologies, our wars. And then there was the darkest thought of all, the one that kept scientists awake long after the observatories went dark. What if this was not their first contact with us? What if 3i, Atlas wasn't the beginning of the story, but the continuation of one we were too young to remember? Perhaps they had visited before. Perhaps they had seeded worlds, guided evolution, or watched civilizations rise and collapse across epochs. The universe is unimaginably old. We are unimaginably new. 2 million years is nothing against eternity. In the end, one truth stood beyond debate. We are no longer alone. And that knowledge, more than any threat, was what terrified humanity the most. Because in that revelation lay a mirror to our own fragility. We've always believed ourselves explorers of the cosmos, but maybe we were never the ones doing the exploring. Maybe we were the experiment, a civilization observed, catalogued, and evaluated by eyes that never blink. 3i, Atlas, didn't just change science. It changed perspective. It forced humanity to confront its most ancient fear, the fear that we are not the first, and we will not be the last. And as its signal continues to pulse across the vacuum, steady, patient, eternal, it asks a question that no telescope, no computer, no scientist can yet answer. Now that we've been found, what will we become? This production is an independent educational project and holds no affiliation with any scientists, universities, or research institutions mentioned. All narratives presented are original interpretations, inspired solely by publicly available research and speculative scientific discussion, intended for educational and inspirational purposes only. The narration employs a synthetic voice created exclusively to enhance storytelling and does not represent any real individual. Our mission is to transform complex scientific ideas into cinematic, emotionally resonant experiences, bridging the gap between imagination and understanding, making the vast universe not just comprehensible, but unforgettable. Through these stories, we aim to remind viewers that science is not only about data or equations, it's about wonder, curiosity, and the unending search for meaning in the silence between the stars.